Now in this section, we'll see the configuration of OSPF routing protocol over DMVPN Phase 1. Now, as per the lab requirement, I got the DMVPN Phase 1 configurations are already ready. So on the router 1, we have configured a multi-point GRE, and on the router 2, router 3, router 4, we got a normal GRE implementations. Now for verification, I can go and verify with a command called show DMVPN. Now the router 1 is having a DMVPN implementation with router 2, router 3 and router 4. Now similar way, if you go and verify the same thing on the router 2, the router 2 is having a point-to-point tunnel established from router 2 to router 1, and you can also verify the configurations by using show IP NHRP detail command. The show IP NHRP detail command shows you that there is a NHRP mappings done manually from the router 2 to router 1. Now we got the configuration of DMVPN Phase 1 here. Now I want to implement OSPF over DMVPN Phase 1. Now again, the same thing like we discussed in case of EHRP, we need to ensure that the first thing we need to allow the NHRP to allow multicast traffic. Now to make that possible, we need to go to the hub router, that is router 1. Now on the router 1, we need to add a command. Now if you verify the configurations here, show run interface tunnel TU1234. Now I got the normal tunnel configuration, so I'm going to say IP NHRP map multicast dynamic. Now this is going to allow you to forward the multicast messages over the DMVPN configurations or DMVPN tunnels. Now the next thing, second thing is there's nothing like split horizon rule here. Now there is one more issue will come across if you're using OSPF. Let me go and configure the OSPF first, and then we'll verify the same. So I'm going to advertise the 10-dot network with a /24 subnet mask, and then I'm also advertising 192.168 1-dot network. That is the LAN interface of the router 1. Now I'm going to copy the same configurations, only the LAN interface will change on the router 2. Let's go to router 2 and configure the same. Now on the router 2, I'm advertising the 2-dot network, and on the router 3, I'm advertising the 3-dot network, and on the router 4, I need to advertise the 4-dot network and 10-dot network. Advertising the 4-dot network. So now if you verify show IP OSPF neighbor, now you may see the neighborship coming up in some routers here. On the router 2, I can see the neighborship has come, but you can see a lot of console messages on the hub router. You can see the neighborship is forced to reset, and then it is from full to loading, probably again it is forced to reset. Now the main reason for this is by default OSPF is going to treat the tunnel interfaces as a point-to-point tunnels. Now we got a tunnel from router 1 to router 2 and then 3 and 4, and by default it is going to treat this tunnel interface as point-to-point, whereas on the routers we are not configuring point-to-points, we are using point-to-multi-points because we got a tunnel interface connecting to multiple points here. Now let's go and verify the same thing on the router 1. If I give show IP OSPF interface tunnel 1234, if I give show IP interface tunnel 1234, you can see the state is point-to-point. Now this is a tunnel interface. Now to fix this one, what we need to do is, normally you'll see the neighbor will come up, goes down, and you'll see a lot of console messages on the hub router. Now to fix this, what we need to do is we need to change the network type. We got a different network types in OSPF. Now we need to change the network type to point to multi-point. Now we need to ensure that we do it on all the sites. We need to go to router 1, router 2, router 3, router 4, and we need to configure them as point to multi-point configurations here. Now in case of OSPF, network type has to match. So to fix this, I'm going to change the network type to point, IP OSPF network type to point to multi-point. And I'm going to do the same thing on the remaining routers as well. The same thing on the router 2, as well as on the router 3, as well as on the router 4. Now once we change the network type, I should see the neighborship should be stable. Now if I give show IP OSPF neighbor, the neighborship is up here. You can see the router 1 to 4, there is a neighborship established, and 1 to 2 also the neighborship is established. I'm still about to see the neighborship between router 1 to router 2, router 3, So let me check the DMVPN. It's up. Now I should see the neighborship has to come up. I can see the neighborship is up. Now if you are not able to see the neighborship, always the first thing you need to check the DMVPN configurations. If the DMVPN tunnel is down, in that case you will not see the neighborship. Now that's something we can verify with show DMVPN command. Now I can see if I verify show IP route OSPF on the router 1 routing table, I should see the routes coming from the router 2, router 3 and the router 4. And similar way, the router 2 has to establish the neighborship from router 1. You can see the neighborship is established here. And if you verify the routing table, I should see the routes coming into the routing table as well. Now there are two things. We don't have any kind of split horizon kind of thing here in case of OSPF. Now in case of OSPF, we need to ensure that we enable the multicast messages to go over the DMVPN tunnels. And the second thing is we need to change the network type to point to multipoint in case of phase 1, because we just have a point to multipoint configuration, because by default the OSPF is going to treat the GRE tunnels as point to point, but in our scenario we are not using point to point, we are going to use them as point to multipoint implementations. So that's the reason we need to change them to point to multipoint. So these two changes we have to do if you want OSPF to run properly on DMVPN phase 1.